Hey there, grade 6. New video for you guys today. We're going to be focusing on comparing and ordering fractions. And so there is a fairly wordy learning target there that students will understand that as the numerator increases and the denominator stays the same, the fraction increases, and I'll explain what that means in a few minutes. And that as the numerator stays the same and the denominator increases, the fraction decreases. And so that will get explained in a little bit as well. So let's get right into it. Okay, so that first part about the numerator increasing in the fraction or the denominator staying the same. So first we're asked to name the two fractions. And so what we have here is over here we have 1/4, and over here we have 3/4. Which is more? Well, the one that's got more pieces shaded in, that is the bigger fraction. That is 3/4. So then what we do is we use those inequality symbols that we've learned about before, and we say that 3/4 is bigger than 1/4. Is 3/4 of something always more than 1/4 of the same thing? Yes, the answer to that question is yes. 3/4 of something is always more than 1/4 of the same thing. So we use these symbols, less than or greater than. They're called inequality symbols. It's like the mouth, I was always told the mouth of an alligator, but it's like the mouth of someone wanting to eat more. So again, similar quantities. We have 2/5 of something, and then we have 3/5 of the same thing, while 3/5 is more. And here we have 2/7 of something and 3/7 of the same thing, and 3/7 is more. And here we have 5/7 of something and 4/7 of something. 5/7 is more. And now we have to figure it out on our own. So we have 1, 2, 3, 4, 5, 6, 7 is our denominator in both cases. And in this case, it's 4/7 and then 6/7, and 6/7 is more. So over here, again, slightly different looking drawings or circles. So this one is 1/4, and the other one is 2/4. And 2/4 is always more than 1/4. Here it's 1, 2, 3, 4, 5, 6, 7, 8. So we have 1/8 of something, and then we have 2/8 of something, and 2/8 is bigger. And here we have 1/6 on the left-hand side, and then 2/6 and 2/6 is more. So let's move ourselves on, a little bit more practice. Now, then, the next question is if Sophia gets 1/6 and Tony gets 2/6. Who gets more? Well, Tony, because he's got 2/6. If Sophia gets 3/6 and Tony gets 2/6, who gets more? Well, in this case, Sophia gets more. So as the denominators are the same and the numerators change, that's going to determine which fraction is going to be bigger. So if the denominators are the same, then whichever numerator is bigger, that's the bigger fraction. Okay? So then here again, which is greater, 1/9 or 2/9? We would say that 2/9 is bigger, and 1/12 or 2/12. 2/12 is bigger. And then what we need to do is order them, these three fractions from least to greatest. And we're really great at reading instructions. And so our smallest one here, since the denominators are all the same, smallest one is 2/7. That is smaller than 5/7. Nope. Let me back that one up. That is bigger than 4/7, which is, 2/7 is smaller than 4/7, which is smaller than 5/7. So that is the fractions in order from least to greatest. And I can show that using my inequality signs. Okay? And then what we need to do is start being able to name fractions between other fraction pairs. Interesting. So here we're asked to write a fraction that's between 5/11 or 5/11 and 8/11. So that could be anything like 6/11 or 7/11. Those are the two options here. Between 3/12 and 9/12, well, that could be anything 4/12, 5/12, 6/12. It could be 7/12 or 8/12 as well. This one between 4/16 and 13/16. And so it's anything from 5 through 12. And then make sure that you put that, whatever number you pick, over 16. between 21 over 48 and 25 over 48, anything that's 22 over 48 through 24. And this one, again, the range is quite large, so anything between 68 and 71 over 131. Sorry, 131. All right, so here we get the opportunity to shade in some fractions. I'm going to try to change and just use a highlighter instead. So this is 1/2, this is 1/3, and that's 1/4. So then what we're looking at here, because these ones are looking at fraction strips and trying to compare them. So 1/2 versus 1/4, well, there's more that's shaded in here. So I would say that 1/2 is bigger than 1/4. Okay, because now these have different denominators, but because these fraction strips are the same length, I see that 1/2 has more shaded in than 1/4. All right, so then what we do is start comparing fractions of the same whole. And so 1/2 meter, we can say, is more than 1/4 meter, because those two things are the same thing. The meter is the same quantity. Okay? We say that 1/2 an hour is more than 1/4 of an hour. We say that 1/2 of a dollar is more than 1/4 of a dollar. And we say that 1/2 of an orange is more than 1/4 of an orange. Okay, but again, these things, they are the same, right? Meter and meter, same quantity. Hour and hour, same quantity. Dollar and dollar, same quantity. And then orange and orange, same quantity. Okay? So what symbol do I use? Well, I say that 1/2 is greater than 1/4, as long as the two things being compared are the same thing. Okay? Now, here's where it gets a little bit tricky. This looks at different wholes. So what we see is this one represents 1/2, and this one represents 1/4, but they're different overall wholes. So just because this is 1/2, it's actually still less than 1/4 because the wholes are different. Our overall wholes are different. These two fraction strips, they are different. And so in this case, stick B, 1/4 of stick B is actually bigger than 1/2 of stick A. Right? That's, if you have a meter stick versus having a 30 centimeter ruler, 1/2 of that 30 centimeter ruler, which is only 15 centimeters, is less than 1/4 of that meter stick. Okay? So it's going to depend on the whole. Now, here's a situation. This is going to be kind of interesting. This is 3/4, and this is 3/8. Notice that the numerators are the same, right? But then we're asked which is more. Well, I would say that 3/4 is more than 3/8. And so what I can notice is that the denominator is lower here. So I've got more of this taken up. So 3/4 is more than 3/8, and I can see this on the fraction strip. Okay, now if I were to draw it using circles, right? And I have two circles that are roughly the same size. And then I have this one that's drawn into 8s. Okay, and I'll change my colors up a little bit. So here's 3/4. And then over here is going to be 3/8. And so we can see also using circles that this fraction, which is 3/4, has way more colored in than 3/8. Okay? And so when we run into the situation where we have two fractions with the same numerators, whichever one has the smaller denominator, that one's going to be the larger of the two fractions, interestingly enough. So then the next thing that they says here is if you cut the same strip into more and more pieces of equal size, what happens to the size of each piece? Well, obviously they get smaller and smaller, right? So here we see one big piece. We have two big pieces in one hole. Here we have three big pieces in one hole, four big pieces in one hole, and this is many, many pieces in one hole. So that moves us on to the next question. Is 1/3 of a pie more or less than 1/5 of the same pie? So here I have 1/3 versus 1/5. So here I have fractions where the denominators are different, but the numerators are the same. Again, right? So this one has a smaller denominator, so 1/3 is going to be larger than 1/5. Okay. What about 2/3 of a pie versus 2/5 of a pie? Again, because this denominator is smaller, that means that this one is actually more than this one. 2/3 is more than 2/5 because this denominator is smaller. It's a weird sort of situation, but that's how it works. Okay, so if you get 7 pieces, would you rather the pie be cut into 20 pieces or 30 pieces? Right? Well, 7 out of 20 pieces versus 7 out of 30 pieces, I'd rather have these ones because these will be larger than these ones. All right, so using that idea, we have to figure out which one is bigger in the pair. So 3/7 or 3/8. 3 out of 7 is bigger than 3 out of 8. Okay, 11 out of 10 is bigger than 11 out of 12. 8 out of 35 is bigger than 8 out of 53. And 6 out of 8 is bigger than 6 out of 9. And again, every time I pick the fraction that has this the denominator that looks like it's less. Okay, that's what I pick. So what I say then is that two fractions have the same numerator and different denominators. Which fraction is bigger? I say that the fraction with the smaller with the smaller denominator. That's the bigger fraction. So then that leads me to, well, what happens if I have two fractions that have the same denominator but different numerators? Which is bigger? Well, we're going to see a couple examples, but in this case, the fraction that has the bigger numerator is going to be the larger fraction. Okay. Would you rather have 2/5 of a pie or 1/2? That one's going to be hard to tell, but normally I would want, right, this is 2/5 and this is 1/2. So again, different numerators, different denominators, but I see that 1/2 is actually more than 2/5. And again, you can draw hundreds blocks to show these fractions. Which of these fractions are greater than 1/2? Well, that would be 82 out of 100 would cover more than half, and then 63 out of 100 would cover more than half. What about less than half? 32 out of 100 would cover less than half, and 47 out of 100 would cover less than half, less than 50 out of 100. Okay, and then so that's a lot of stuff that I threw at you today in about a 15-minute video. Get to work on the practice in the workbook. Do your best, and I'm available for questions if you have any.